Last episode we learned how to go from observable to signal using toSignal. One line, no subscribe, no cleanup, done. But sometimes you need to go the other direction. You have a signal, maybe a search input, maybe a selected filter, and you want to plug it into a RxJS pipeline. Debounce it, switchMap it, send it to an API. That's exactly what toObservable does. Let's go. Let me show you a concerted problem. We have a search input bound to a signal. This is our signal, this is our function, and this is our input, and this is input event when we emit our function. Every keystroke updates the signal. For example, we need to find, for example, iPhone. Now we want to search products by that query, but we don't want to fire an HTTP request on every single keystroke. We want to debounce it, wait 500 milliseconds after the user stops typing, then search. Debounce is an RxJS operator. Signals don't have debounce, so we need to get back into observable world. And that's where toObservable comes in. In the previous video we create signal from the observable. Now we do the reverse bridge and create observable from the signal. What it does? toObservable creates an observable from a signal, emits a new value whenever the signal changes, works with the full RxJS ecosystem, debounce, switchMap, or tap. Auto cleanup must be called in injection context. toObservable use effect under the hood. Every time the signal changes, the observable emits. Under the hood, it uses Angular's effect, the same reactive primitive that tracks signal reads. This means it's fully integrated with Angular's change detection. And just like toSignal and inject, it must be called in an injection context. Now we can create our observable. So type protected search query $. It means it's observable. And now we use toObservable and type our search query. That's it. Search query $. Is now an observable that emits every time the search query signal changes. We can subscribe to it, pipe it, do anything RxJS can do. Now we can change it. So let's pipe to make sure we have the bounce time, like we said, 500. The bounce time. Import. Okay, now type switchMap. We need to find our shops from shop service. Now we have query. Shop service, I have search products. Now type the query. And now if we want use this in HTML, we need to use async, we need to subscribe this, but we can exchange this to signal again. So rename it to maybe result, type toSignal again, like this, and remember we need initial value in our signal. Now we have empty initial value. So now let's change our HTML. We can delete this function. Now go here. On the input, we set a new value in our signal, like that, and every time signal changed, observable emit our function search products. Okay, now we can display our results. We use for shop product of result. We have result there, yes. Okay, and we need to track, maybe by index only. Now let's display our product. So product name and product price. Okay, we need to change, because a search query is a string signal, so we don't want to have undefined value. Sorry. Save. Okay, now let's test our function. I changed some style in HTML, so you can check this on our GitLab. So now let's find the desk mat. Okay, we found our product. In maybe 500 millisecond debounce time is too low. You can change it for 2000 or 3000 is 2 or 3 seconds. One gotcha worth knowing. toObservable emits asynchronously in the next microtask, not synchronously. This is because it uses effect under the hood, and effects are always scheduled asynchronously to prevent infinite loops. For 99% of use cases, search inputs, filters, API calls, this doesn't matter at all. But if you write a synchronous unit test and expect the observable to emit immediately, you will need to account for this. Just something to keep it in the back of your head. Let me show you the full pattern clean from scratch. Okay, we have two signals because we don't want async pipe, subscribe or whatever. We have toObservable, this search query, because we want to use RxJS operator like debounce time or switchMap. And we have initial value because it's a signal. Now we can add one more RxJS operator. This is distinct until changed. It compare value from this search query. If it's the same, this not emit. Okay, now we can also add here something like this. Now, if the search is empty, we return an empty array immediately instead of hitting the API. Small detail, big difference in production. The whole component, no ng init, no subscribe, no manual cleanup. Two signals, one pipeline. This is what modern Angular looks like. Let's recap. toObservable takes a signal and turns it into an observable. Every time the signal changes, the observable emit, it uses effect under the hood, so it's async. But for real-world use cases, that doesn't matter. The real power is combining toObservable with toSignal. You get the full RxJS toolkit available to you with signals on both ends. Your template stays clean, your component stays clean, and the RxJS pipeline does exactly what it is good at. That's the bridge complete. Observable to signal with toSignal, signal to observable with toObservable. Next episode is the last Angular video for now. We will wrap up this RxJS and signals block with a practical decision framework. When to use signal, when to stay in observable, when to bridge between them. After that, we are switching gears for a couple of weeks. Java, Spring Boot, backend architecture, but Angular is not going anywhere. We will be back with more micro frontends, statement management at scale, performance patterns. This series is just getting started. See you in the next one.